This module is called Planning for Growth. And the first slide says scaling servers and services. So what is scaling? Scaling is like sizing, like going from small to medium to large. Host scaling is really about servers. And I guess two questions that we can ask ourselves is, what are we serving? That's a key question to ask in terms of making that determination about when do we need more servers. Another one is called thrashing. We'll talk about thrashing here in a moment. So how do we add servers? Well, there's two ways, typical ways. One is physical, and the other one is virtual. On the virtual one that we'll discuss, obviously, you have to have a physical platform to build on your virtual instances. But we'll talk about the differences there as we proceed forward with this presentation. So when are they needed? When do we need more servers? And typically the answer is, it depends. The first part of that question about, well, what are we serving is really the depend part. If we're serving up multimedia like YouTube and we're getting more into providing these kinds of multimedia services, they are bandwidth intensive, especially for the video streaming services. The resources like the random access memory, the CPU resources, you have to monitor them very closely. As utilization increases, the server's performance may start to decay, may start to actually degrade, and so it's important at that point to be considering about adding more resources to your systems. Registration sites like travel visa applications are another one where you may actually need more resources, more servers. They return a large amount of session state information, so you need to monitor the concurrent connection thresholds. As connection increases, so does server response time. This can cause connections to drop, and so it's another thing to monitor, keep an eye on, and answering that question, so when are they needed? Thrashing is another indicator. Thrashing is a clear indication that something is wrong. Thrashing begins when the RAM resources are actually being exceeded. So the operating system is involved in a continuously swapping arrangement between the RAM and the page file, or what's called the swap partition. Thrashing usually results in an unstable system and causes the system to crash. And that's not a good thing to happen, particularly when you have live customers on those systems. So keeping an eye on your system resources is important. So we talked about how to add servers, and one of them is the typical way of adding physical servers, of going out to make a purchase request. You wait for the delivery, you confirm your delivery, that all your parts are ordered, and the inventory for the servers have the right configurations with the software. You install it in your best available network switch. You configure the switch ports correctly. You install the operating system onto the server, the application software. You update the load balancer configurations to include the new server. You update the maintenance plan to include new servers. And as you can imagine, this process takes a lot of time. For a typical organization, it can be as much as 3 to 6 months. So if you need a server in the next moment, this is not the way to do it. The other way to do it is by adding virtual servers. Now, this presumes that you've taken the time to design an architecture, a physical architecture of servers, a server farm, and created the virtual operating systems that allows you to really run these servers, these physical servers, as virtual servers. And the simple way to add a virtual server is to right-click and clone, so it's available to you immediately. Load balancing virtual servers is on the left-hand side, you see a bad configuration. On the right-hand side, you see a good configuration. Now, this slide obviously assumes that all the servers are running a typical kind of load. Sometimes that isn't exactly the case. So this is really simply an example of load balancing between server 1, server 2, and server 3 in a way where there's an equal distribution of the virtual machines that are running on these servers. Load balancing for network connections is also important to prevent server thrashing and improve application availability. And again, this is about the traffic inside of the network and making sure that you can balance the network as well. There's also traffic that goes outbound from the network when connecting to the internet, and sometimes you need to make sure that you can load balance that as well. So load balancing for maintenance and outages, as I talked about briefly, is about allowing for when you take a server down that the rest of the servers can carry the load of that application that was running on that server. It's really nothing more sophisticated than that. But there's another key benefit, and that is for unplanned outages. So a maintenance is a planned outage, and unplanned outage is when something crashes. So a server may fail on you. This allows user services to continue uninterrupted in the event of the failure when you have load balancing taking place. There's another concept called high availability. High availability has to do with hardware, with the network, and the applications. We'll talk about hardware, high availability, network, and applications here in a moment. So the first one we'll talk about is called high availability for hardware. And the arrangement is called RAID, which stands for Redundant Array of Independent Disks. We have a server with an operating system and 2 network cards. The operating system has 2 drives, hard drive 1 and hard drive 2. The second one is obviously our backup. And for the network cards, we also have 2 network cards, NIC 1 and NIC 2, where the second one serves as the backup. So in this animation, as you can see, we've lost the first hard drive for some reason, and so the second one is there available to carry the load. But you can also lose a network card, and so here in this arrangement you have 2 network cards, so the traffic can still go outbound from the server and connected over the second network card to the rest of the network. There are 4 types of a RAID: type 0, type 1, type 5, and type 1 plus 0. These are the typical arrangements as you see here. And the differences are in striping, mirroring, and parity check, and you can see the designations between the different types of RAID types there. The next one that we'll talk about is network high availability, in which you take a server and you connect it to 2 different switches. So you can have internal redundancy, and you can also do something like this for external connections as well. So you can get redundant routes, so should one connection path fail, the other one is available there to let the traffic go out. The third kind we wanted to talk about is high availability for applications, and there are really 2 kinds: keep alive heartbeats and database log shipping. In this case, we have 2 servers. Server A is in standby in this case, as you can see, and server B has become the active. And there's a communication that has taken place between the 2 of them, which is asking the question, are you there? If the answer is yes, then the active one stays active, and the standby one stays on standby. But as soon as the answer turns into no, then that's when the switch takes over. The answer is no, then the standby one becomes active, and the one that is not available goes on standby as soon as it's repaired and comes back available. The database log shipping is really for databases, as you can see, in terms of maintaining a backup for the database application, where you have an active database as the primary, and you have the standby database in case the primary should fail. And in critical applications that have to be maintained up all the time, these are 2 arrangements that are found where you have not just the servers, but the network and the applications in a high availability arrangement. Yeah. So bandwidth is another consideration to use as a semi-fixed resource. Semi-fixed means that you can scale it, you can grow it when you need to. So the key thing is to plan ahead, because mobile really does change everything. The first thing that changes is rich media. You're going to have more images, more video, and so there's going to be a higher demand for the bandwidth. The other reason to think of and to consider bandwidth as part of the resource for availability is you have to plan for peaks, and sometimes for unplanned outages, such as may occur in a security attack called a denial of service attack. So there are multiple ways to get to the information if you have this kind of an attack. And one of the ways is to distribute the content, get it closer to where it will be used. There's burst bandwidth capacity capabilities that are available as well. And think of the user experience, particularly when there are many things that are happening that maybe weren't planned ahead of time. This is the kind of planning that you need to think of ahead of time. Well, here's an example of planning for future growth in bandwidth. There are two types of peaks that we'll talk about. One is for a planned event, something that is coming up on the calendar that you already know about, for which there's going to be a lot of video utilization. Another one is an unplanned peak that may occur, as we described earlier, in a denial of service attack, in which it's going to exceed your available bandwidth by a great amount. So planning for both of these, the predictable in terms of what's coming up on the calendar, especially as we utilize more of the video and images inside of mobile, and the unpredictable, as we talked about in the security example, are the two reasons for why we need to be thinking about bandwidth as a key resource for availability. So the summary. Mobile will create additional IT infrastructure stresses, downloading video streams, adding pictures of or their own videos in terms of people who are interfacing with an application that allows them to do that, conducting transactions that connect with internal enterprise resources like databases, engaging the help desks with chat sessions, providing feedback on the performance of a service. This is all the many different kinds of reasons why mobile will change the way we use the IT infrastructure today. We're causing more demand, more stresses on the existing architectures that exist today. So part of the way to manage this growth is with scaling, with high availability and load balancing.